This video is about inverse trigonometric functions and understanding the principal solution. So if we look at our 6 arc functions or inverse trig functions, what we have is we have certain restrictions that we have to enforce in order to be able to make them a function. Otherwise, it won't pass the vertical line test, and therefore it wouldn't be a function. Now, just recall that if we are trying to have a function that's one-to-one, so a one-to-one function means that it has an inverse. It has to pass both the horizontal and vertical line test. We learned that in Honors Algebra 2 Trig in the first unit of the year. So basically what that means is all of these values for arcsine, arccosine, arctangent, arccotangent, arcsecant, and arccosecant are the restrictions that we have when we are kind of dealing with these sorts of things. And basically, one way that you can kind of easily remember it is if you're taking a look at the graph, we want to not have any sort of horizontal or vertical line situations, and we typically center them around 0. So in this case, sine, if we go from negative pi over 2 to pi over 2, inclusive, notice if we kept going here, we would fail the vertical line test. And we also want to make sure that we cover the entire domain and range of sine. So that means that from negative pi over 2 to pi over 2 would be our domain of sine of x that would then translate into being the range of sine inverse. So whatever we have here, if we're doing the inverse function, so sine inverse, then our domain is going to be negative 1 to 1, and our range is going to be negative pi over 2 to pi over 2, because remember, the x and y values flip when we are dealing with inverse functions. So for cosine, centered around 0, we can't go, or as close to 0 as possible, we can't go like this, because that does two things that aren't very good for us. A, it doesn't pass the horizontal line test, and B, it doesn't cover all values of the range of cosine. So as close to 0 as possible, we're actually going to go from 0 to pi in our function. And so when we look at this, we have 0 to pi. So cosine inverse has domain negative 1 to 1 and range 0 to pi. Likewise, if we're looking at tangent of x, negative pi over 2 to pi over 2, and cotangent of x, when we graph one period of that, it's 0 to pi. So if we're doing the inverse functions of those things, the domain for tangent is going to be the range output of this graph, which is negative infinity to infinity, because there are no such values that end up being restricted in the range of tangent, and therefore in the domain of arctangent, we're actually okay for all of those values. But then the range is going to be negative pi over 2 to pi over 2. And that's my fault, because these should not be brackets. They should be parentheses, because it doesn't actually hit those values. Likewise for cotangent. So then arccotangent, the domain is going to once again be negative infinity to infinity, because there are no restrictions on the range of cotangent. So the domain of arccotangent is not going to have any restrictions. And then the range is 0 to pi. And likewise for cosecant and secant, we have basically the same rules that we had for sine and cosine. So if we take cosecant, which is the sine graph's inverse, if we want to take the inverse of the function cosecant, what we would do is we see that the domain for cosecant is negative pi over 2 to 0 and 0 to pi over 2. And so then that becomes the range of the cosecant inverse function. And the domain is negative infinity to negative 1 and 1 to infinity. And likewise for secant, we have the same situation because we want to make sure that we hit all values in the range of secant as we go to our domain for secant inverse. So when we look at problems like this, if we look at something like when does cosine inverse of cosine end up getting you back what you started? If we look at the graph of cosine, from 0 to pi, everything will get you back what you started with. But if you plug in anything else, so for example, if you plug in, let's say, 7 pi over 4, you won't get 7 pi over 4 back because cosine inverse only has a range from 0 to pi. So what you would get back is pi over 4 because it has to have the exact same y value in cosine, but it has to be within this domain of cosine and this range of cosine inverse. So the only times you're going to get back what you started with are 0 to pi in cosine. Likewise, negative pi over 2 to pi over 2 for sine. So those are the values that the inverse of the original function gets you back what you started with. So let's take a look at some problems, like sine of 5 pi over 4. That would be in the third quadrant. And so if I look at what sine is there, it's negative root 2 over 2. Sorry about the little negative. And then when I look at the graph of sine, if I try 5 pi over 4, I'm not actually going to get that back when I plug it into sine inverse because my range is negative pi over 2 to pi over 2. So I would have to get some value in there that has the exact same y value in sine, but is within the range of sine inverse. So that's going to be negative pi over 4. Problem 2, tangent inverse of negative 1 is negative pi over 4. Now, we don't have to worry about it in a problem like this where the original function is on the outside because I can just find what the cosine of negative pi fourths is. Cosine of negative pi fourths is root 2 over 2. It is in the fourth quadrant, and cosine works in the fourth quadrant as a positive value. So I have positive values there. So I can just straight up do that one. I don't really have to worry about it. And it's the same thing in number 3 because the original function is on the outside. So if I take arc cosine or cosine inverse of negative root 3 over 2, I would figure out that that's 5 pi over 6 because cosine inverse works in quadrant 1 and quadrant 2. So then I just find tangent of 5 pi sixths, and that's negative root 3 over 3. I don't really have to worry about rearranging it. But in problem 4, I would have to worry about rearranging things because cosine inverse is on the outside. So sine of 7 pi sixths is in the third quadrant. That's negative 1/2. But cosine inverse of negative 1/2 is not going to be 7 pi over 6 because that's outside of my range for that. It's outside of 0 to pi. So I would have to go back here, and my answer would be 5 pi over 6. Now for non-unit circle values, I basically have to kind of figure out what's happening with the function. So arctangent domain is negative pi over 2 to pi over 2. So because of that, 4 pi over 7, which is bigger than pi halves, what I would have to do in order to understand what's happening here is I have to kind of figure out where I need to be. So 4 pi over 7 is in the second quadrant. And so in order to get a negative value, I need to go to the fourth quadrant and basically subtract pi. So as I do that, I end up getting negative 3 pi sevenths. For sine, the domain of sine is negative pi over 2 to pi over 2. Sine of 3 pi over 5 is once again in the second quadrant. It's slightly bigger than pi over 2. But in the case of sine, sine is positive in the first and second quadrants. So I'm not going to be subtracting pi because tangent is negative in the second and fourth, whereas sine is positive in the first and second. So really what I want to do is I want to end up getting a graph that has, or a value in the first quadrant that has the same angle with the reference angle. So that means I'm going to be doing pi minus 3 pi fifths, and I would get 2 pi fifths as my answer. Tangent of sine inverse. Well, in this case, I'm not too worried about it because the outside angle is the outside function is the original function, so I don't have to worry about it too much. So if it's in the first quadrant, it can kind of stay there. So I have this triangle, then that means tangent is 1 over root 8 or 2 root 2 over 8 or root 2 over 4. And then same thing with secant and tangent here. Tangent inverse is going to be in the first quadrant if it's positive, and then I can graph, or I can find secant, which would be root 5 over 2. Now, if we're going to find the exact values for these things using trig identities, in this case, this looks like sine of a plus b, except a and b are angles that are not given in terms of angles, they're given in terms of these inverse functions. So I do know that the cosine inverse of 1/2 is pi thirds, because I can draw the picture, but here's what A and B look like in terms of triangles. So what I can do is I can rewrite it if I want like this, or I can just use the triangles. So sine of A is going to be root 3 over 2. Cosine of B is going to be 4/5, and so on. And so I can just use the trig identities to get me an answer. Same thing with number 10. This looks like cosine, so I'm going to use a cosine trig identity. Draw my triangles, pi over 4, and then cosecant inverse of 5/3 would give me a triangle that looks like this. So then I just do cosine of A, cosine of B, sine of A, sine of B, and multiply them together. Then I have cosine of 2 times an angle. So I need cosine squared and sine squared of that angle. Draw the triangle. Do cosine squared and sine squared. And get the answer.